Welcome back, everyone. In this video, we're going to do some more examples with the quotient rule, and we're going to use that to review all of the various skills that we've talked about so far since the last test. So, here's a typical question, and this is in fact a preview of what we'll be doing basically all of next week, which is to say I've been given a function, and I want to know where the tangent line is horizontal. And before we even think about this question, I want to remind you, tangent line horizontal, that means the slope is 0. Okay, and the slope is 0, that means I'm looking for where the derivative is 0. So ultimately, just from this red underlined part, I know that what this question is really asking me to do is to take the derivative of this function, set that equal to 0, and then solve. Okay, so let's take the derivative of this function. So the numerator here is 2x squared plus 3x minus 3. The denominator is e to the x. So a prime is 4x plus 3. B prime is also e to the x. Via the magic of the quotient rule, we have that f prime of x is equal to a prime b minus ab prime all divided by e to the x squared. So let's FOIL out this mess. And now I want to simplify this, of course, as much as I can. So that's going to give me minus 2x squared times e to the x. I have a 4x e to the x and a minus 3x e to the x. So that is going to be a plus x e to the x. And I have a plus 3 e to the x and a plus 3 e to the x. So that is going to be a plus 6 e to the x. Okay, and this denominator here is going to be e to the 2x. Okay, so I want to simplify this just a little bit more. I'm going to remember that the thing we're looking at here is the derivative of our function f that we started with. And I'm going to factor a minus e to the x out of the numerator here. And I'll notice now, actually, I can cancel this e to the x with one of the two e to the x's in the denominator. And so, in fact, my numerator is going to be this. Divided by e to the x. Okay, so that is me having simplified the derivative. Here we have to pause, reflect, and remember what the question actually asked, which was, at what points on the graph is the tangent line horizontal? Okay, which again meant we needed to take the derivative, which we've done, but we need to figure out when the derivative is equal to 0. So I'm now going to take this thing that we found and set it equal to 0. Now, this is a fraction, and I want to know when it's 0, so I only have to look at the numerator. I can multiply both sides by minus 1 to clear out that minus sign. And then I can factor this. Okay, and so I believe that will work. So I've got a minus 4x plus 3x, that's minus 1. Those multiply together to be that. And so I get that x is minus 3 halves, or x is 2. Those are my two solutions. And so that tells me that there are 2 points where the tangent line is going to be horizontal. One of those 2 points has x-coordinate 2, and the other has x-coordinate minus 3/2. And of course, how do we find the y-coordinates? Well, these are points on the graph, so I need to plug these two things back into f of x. And I want to reiterate that it's maybe tempting to plug these numbers into the derivative, especially because if I'm looking for something to plug these into, I looked at the derivative most recently. However, if I plug these into the derivative, I had better get 0, because that's how I found these 2 points. If I don't, something went wrong. No, I need to plug these into the original function. So here, creeping up at the bottom, is my original function again. So f of 2, if I go ahead and calculate it, that's going to be 8 plus 6 minus 3 over e squared. Okay. 8 plus 6 is 14, minus 3 is 11, so I'll write this as 11e to the minus 2. And if I take f of minus 3/2 instead, then I'll get this. Note an e to the negative power in the denominator is the same as that e to a positive power in the numerator. I will get a 9/2 minus 9/2 minus 3. So those two pieces will cancel, and I will end up with, in fact, minus 3 e to the 3/2. And so these two are my 2 points on the graph where the slope is horizontal. Just to make this a little more concrete and make sure we understand what we just did, I've pulled up a graph here of our original function f of x. So this is f of x equals 2x squared plus 3x minus 3 divided by e to the x. We found all the spots where the tangent line is horizontal. Look at this graph and make sure you can see where those points are. So I've circled on screen where they are. So there's 2 of them that you can see both of in the graph. And we should make sure we believe that these 2 answers are plausible coordinates for those 2 points. And indeed, at this one, this 2 comma 11e to the minus 2nd, that's that point. And the minus 3/2 minus 3e to the 3/2, that's that point. So here we have another exercise where our goal is to apply the quotient rule, try not to get too lost in the algebra, simplify some stuff, and then plug in the number minus 2. So here our a is the square root of x, our b is the natural log of x. Okay, so here are our pieces that are going to go into the quotient rule. So now we're going to write down f prime of x. It's going to be a prime b minus ab prime all divided by b squared. Okay, so let's try and simplify this. So instead of having this divided by natural log of x squared in the denominator, I'm going to write this as 1 over the natural log of x squared times, and then I'll write down this thing. And square root of x over x is actually 1 over the square root of x. Why is that? This is an x to the 1/2 power in the numerator. This is an x to the 1 power in the denominator. So that's the same as 1 over x to the 1 minus 1/2. Now these two things aren't so far off from being over a common denominator, and so I can write this as 1 over the natural log of x squared times natural log of x minus 2 divided by 2 root x. Or we can write this as the natural log of x minus 2 divided by twice the natural log of x squared times the square root of x. But that is f prime of x, and the question asked for f prime of e to the minus 2. This is actually one of the most common errors on tests, finals, and so on, is people doing this and feeling like, okay, I've done enough work, and then declaring this to be their answer, rather than actually answering the specific question. So you should make sure, before you turn in an exam, that you go back and check that you actually answered the direct question that you were prompted to answer in each question. Okay, so let's now find out what f prime of e to the minus 2 is. It is going to be the natural log of e to the minus 2 divided by 2 times the natural log of e to the minus 2 squared times the square root of e to the minus 2. Okay, which I can write much more easily. The log of e to the minus 2 is just minus 2. So the numerator here is minus 2 minus 2. The log of e to the minus 2, well, it's still minus 2. And then when I square it, it's going to be plus 4. And the square root of e to the minus 2, well, remember, square root is the same as the 1/2 power. So this is e to the minus 2 to the 1/2 power, which will be e to the minus 1. So this is minus 4/8 e. Or, if you like, this is minus e over 2. And that is our final answer. So let's look at this question next. We have a function, and we're asked to find the equation of the tangent line at the origin. So to do that, I'm first going to need the derivative of f, which I'm going to need the quotient rule for. So having completed our little tablet up here, we can follow the quotient rule to write down that the derivative is a prime times b minus a times b prime. And this is all divided by b squared. Let's simplify this a bit. Okay, so there is a minus x squared. There's a minus 2x and a plus 2x, so those are going to cancel. And then there is a plus 2. And that all seems to be divided by an x squared minus 2x plus 2 squared. And so that is our derivative. Once we have the derivative, we can move on to the slope. Now remember, the origin is just the point 0, 0. So my slope is going to be f prime of 0, which is going to be 2 over 4, which is 1/2. And by virtue of being the origin, that's also the y-intercept. And so that tells me that the equation of my tangent line here is just y equals 1/2 x. Again, that's because normally it would be mx plus b. M is a half, but b is 0. Here's a graph of our f of x. That is, this is a graph of x over x squared minus 2x plus 2. And our answer, y equals 1/2 x, which was supposed to be the tangent line at the origin. First thing, looking at the graph, hey, it really does look like the tangent line at the origin. Great, so we can be almost positive that we got the right answer. But there's one other thing that leaps out at me in this question. which is the fact that this tangent line actually intersects the graph somewhere over on the right. And so a perfectly reasonable question is, where do the tangent line and the graph intersect? All right, so let's attempt to find the coordinates of this point. So, reminder, I'm just asking to find the intersection between two graphs, both of which I have equations for. So to do this, I just have to set those equations equal to each other. So, in other words, I am going to set our formula for f equal to our formula for the tangent line. So now I'm going to solve this by cross-multiplying. And these two x's are going to drop off. I can factor an x squared out of this. And so I learn that, in fact, the tangent line intersects the graph at x equals 0 and x equals 2. Now, if you look at it, that x equals 0 intersection is actually the intersection we knew about to start with. So that's definitely not the point we're looking for. And so, in fact, the point we're actually looking for is this one here with x is 2. And so we can plug in 2, comma, and then we can figure out the y coordinate by plugging 2 into your choice of f or this tangent line. I'll plug it into the tangent line, where I will see that it is 2, comma 1. Okay, and so those are the coordinates of this intersection point. Our last example of the day concerns this graph, where there's a lot going on, so I want to describe what's going on, and then as I describe it, I'll also say what the question is. So first of all, the function in the graph is 2x over x plus 1. And the blue line is the tangent line at 1, comma 1. And the red line also passes through 1, comma 1, but it is perpendicular to the blue line. That's all set up. And I could, of course, ask you, hey, what's the equation of the blue line? What's the equation of the red line? Or anything like that. But my actual question is, what is this point? That is, what is the point where the red line intersects the graph, other than the point 1, 1, where we already know it intersects the graph? So let's slowly piece this together. So let's start with the fact that I'm going to need the derivative of f in order to figure out any information about the blue line. Okay, so I'm going to do that using the quotient rule. And that's going to give me this formula for the derivative. Now, the derivative can tell me something about the slope of the blue line. Namely, the slope of the blue line, that must be equal to f prime of 1, which, if I just plug in 1 here, that's 2 over 4, which is 1/2. Now, at this point, you probably can barely stop yourself from finding the equation of the blue line, which is fine. It won't hurt anything if you find the equation of the blue line. But actually, what we want is we want the equation of the red line, because that's the line whose intersection with the graph we want. And so, we have to figure out what is the slope of the red line. Well, the slope of the red line, because it is perpendicular to the blue line, its slope is the negative of the reciprocal of the slope of the blue line. So it is negative 1/2 to the minus 1, which is to say that the slope of the red line is negative 2. So given that the red line has slope minus 2, its equation must look like y equals 2x plus b, but it passes through the point 1, comma 1, which means that 1 is minus 2 plus b, so b is 3. And so that means the equation of the red line is y equals minus 2x plus 3. And now we're actually almost done, because the thing I'm looking for is the intersection of the graph with the red line. And to find that, I can set the equation of the red line equal to the equation of the graph. And now I can go ahead and solve this equation. So I'll put an over 1 there, cross multiply. I'll go ahead and push everything over to the right. So I'll get 2x squared plus x minus 3 equals 0. So this would better factor like this. And if I squint at this, I'll come up with this factorization. Now, of course, this x equals 1 here, this is telling us that the red line intersects the black graph at x equals 1. We already knew that. That's not the point we're looking for. The point we're looking for is this one, which has x being equal to minus 3/2. And so my point that I have circled there is minus 3/2, comma, and then I'll get the y-coordinate by plugging this back into the original line over here. That is, I will get minus 2 times minus 3/2 plus 3, which is 3 plus 3, which is 6. Okay, and so my final answer for the coordinates of that point are minus 3/2, comma 6. I'm going to go ahead and wrap this video up here, and also wrap up talking about section 3.7. I'll note that a lot of these questions are just a matter of practicing the formulas and making sure you're getting the right answers. And if you're not, then talking to someone to figure out what's going wrong. So this is definitely a great time, if you've not already been doing it, to take advantage of my office hours or the math clinic or whatever, to, when you check your answer at the back and find out it's not quite right, to figure out what you're doing wrong so that you can fix it, so that by the test you could be doing all of these things as accurately as possible. In the next section, we're going to be talking about what derivatives mean in real life. That is, we're going to be talking about why physicists care about derivatives, and why economists care about derivatives, and so on. But that's all for now. I'll see you all next time.